All right, next example. Integral secant to the sixth x. So this falls under the category of the power of secant is even. And in that case, we break off a factor secant squared x, which leaves me a secant to the fourth x. Okay, so now what I have to do is write that secant to the fourth x in terms of tangents. And the way that I'm going to do that is first, I'm going to write secant to the fourth x as secant squared x squared. Okay, and then I'm going to use the same identity I used 2 examples ago. I'm going to replace that secant squared x with tangent squared x plus 1. All right, so why don't we go ahead and do our substitution? So let u equal tangent x, which is going to make du secant squared x dx. So this ends up being the integral of u squared plus 1 squared du. All right, so now let's multiply that out. I think I've used this trick once already in this lecture, squaring a binomial. But just in case you're rusty on your beginning algebra, what I'm basically doing, or not basically, what I am doing is foiling this thing. So that's going to give me, oops, extra equal sign there. U to the fourth plus u squared is 2u squared plus 1. All right, and now this is just another easy backwards power rule. So we're integrating u to the fourth plus 2u squared plus 1. Darn it. So when I set these up on the tablet, I try to predict whether the problem is going to take me 1 page or 2. And I think this is just about my, just about the worst record I have in this lecture of predicting that correctly. On the ones that I thought it was going to take me 1 screen, it's taken me 2. And on the ones it's taken me 2, it's only that I thought it would take me 2, it's only taken me 1. All right. Oh, well. Okay, so u to the fifth over 5. Integral 2u squared is 2u cubed over 3. And then the integral of 1 with respect to u is u. And of course, it's not about u, so the final answer is tangent to the fifth x over 5 plus 2 tangent to the third x over 3 plus tangent x plus c. All right, isn't this fun? Okay, well, now we're going to get into the really fun problems because the next 2 examples are the sort of miscellaneous category. So this particular integral that you're looking at right here, integral secant cubed x, is one of my favorite integrals. And this definitely goes in the category of the reason that I know how to do this is because somebody showed it to me once, right? You know, there are certain things that you can hopefully figure out, and then there are other things that you know how to do because somebody showed you. Well, this can definitely go into that second category. So this is a very special integral. It's an odd power of secant. We don't have any guidelines about that. All I told you is it's either maybe integration by parts or some kind of reduction, you know, break it down to a simpler integral. Well, this one happens to be integration by parts. So we're going to let u equal So remember, this is where part of the integral is u and the other part is dv. And we have to make dv something that we know how to integrate. We technically know how to integrate secant x dx, but it's much easier to integrate secant squared x. Okay, so that's what we're going to do. And then u is secant x. So on this side, we differentiate. That's going to make du secant x tangent x dx. And on this side, we integrate. The integral of secant squared x dx is tangent x. All right. So remember how this works. Integral u dv is equal to uv minus integral v du. So that's going to make integral secant cubed x is going to be u times v, which is secant x tangent x, minus integral v du, which is going to be secant x tangent squared x dx. All right, so now let's talk about integral secant x tangent squared x. And let's call that the red integral, because now I'm going to come down here and work with that integral. Okay, this also falls into the sort of miscellaneous category. We don't have an odd power of tangent. We don't have an even power of secant. So what I'm going to do with this one is replace tangent squared x with secant squared x minus 1. And this integral turns into integral secant cubed x, gosh, that looks familiar, minus secant x dx. All right, so here's what we have. Going to go on to the next page. I'm sure I left 2 pages for this one. Okay, going back to the main integral, which was integral secant cubed x. Okay, the first term was secant x tangent x. And then we had the red integral. And the red integral turned into integral secant cubed x minus secant x dx. All right, so hopefully you can kind of see where this is going. This trick came up once or twice under integration by parts. That means that integral secant cubed x is going to be secant x tangent x minus, I'm going to break this now into 2 integrals, secant cubed x dx, and then minus becomes plus, integral secant x dx. All right, so we were trying to figure out integral secant cubed x dx, and now on the other side of the equation, we have an integral secant cubed x dx. So let's add this integral to both sides. I remember when I was talking to you about this under integration by parts, when I first saw this kind of thing happen, I thought it was a cheap trick. I didn't feel like we were actually solving the problem. But we are. Okay, so that leaves me with secant x tangent x. All right, now way back in, gosh, I think it was section 7.2. I showed you how to evaluate integral secant x dx. That's another very dirty trick. And then I said from now on, you can just do this by formula. And you, if you're in my class, you have the formula sheet that I gave you under section 8.1, and I'm just about positive this formula is on there. It's natural log absolute value secant x plus tangent x. And I guess I should put a plus c over here. Okay, so we are almost done. The only thing left to do is to get rid of this 2 sitting out front. Okay, I think I'll leave this answer in red. It kind of feels like it deserves it. So integral secant cubed x dx is equal to 1/2 secant x tangent x plus natural log absolute value secant x plus tangent x, and don't forget the plus c. All right, and that's the kind of crazy thing. This is bothering me a little bit here. This is the sort of crazy thing that happens in the miscellaneous case. Okay, that looks a little better. All right, I have one more crazy example to show you. And that's this one, the integral of cotangent to the 6th 2x. Now, let me first say that all the tricks that apply to tangents and secants also apply to cotangents and cosecants. So you can use the same general guidelines, just swap out the functions appropriately. So if you have an odd power of cotangent, that's easy. If you have an even power of cosecant, that's easy. Well, we have neither one of those things, so that puts it into the miscellaneous category. So what I'm going to do with this is first break it into integral cotangent to the 4th 2x times cotangent squared 2x. And then I'm going to use my identity for cotangent squared. And before I started the video, I did practice this problem to make sure that I remembered how to do it. And that was when I did my derivation of the identity. So I don't need to do that. I mean, I need to do it every single time, but I don't think I need to show it to you every single time. All right. So by the pre-calculus Pythagorean identity, cotangent squared 2x is cosecant squared 2x minus 1. All right, so now I can break that into 2 integrals. The first one is going to be integral cotangent to the 4th 2x cosecant squared 2x dx. And then the second integral is integral cotangent to the 4th 2x. Okay, that first integral is going to be a very easy substitution. So we'll save that till the end. And this one, so this is an example of what I was calling reduction before. We took integral cotangent to the 6th, and now we've got it down to integral cotangent to the 4th, which should be a little easier. So this will now be the red integral. All right, so now let's start working on the red integral. And I'm going to do it the exact same way. Integral cotangent to the 4th 2x. I'm going to write that as cotangent squared 2x times cotangent squared 2x. I'm going to change that second cotangent squared 2x into cosecant squared 2x minus 1. And that breaks into 2 integrals. The first one is cotangent squared 2x, cosecant squared 2x. And the second one is integral cotangent squared 2x. All right, so it started out 6th power, got it down to 4th power, and now it's 2nd power. So we're almost done breaking this down into the simplest parts that it can be. All right, I don't think we've ever had to do this before, but now let's do a blue integral. All right, here we go. You may, at some point, have done this integral with tangent squared. I think that's actually a Calc 1 integral. The way you do this integral is just write it in terms of cosecant squared minus 1. So cosecant squared 2x minus 1. All right, and now finally, we have an integral that we can evaluate. The integral of cosecant squared is negative cotangent. And by baby u substitution, it's going to also have a 1/2 sitting in front. And then, of course, the integral of minus 1 is minus x. All right, so now, let's go back to the red integral. We'll work our way back to the beginning. All right, so the red integral was cotangent to the 4th. Okay, so what we have is that integral cotangent to the 4th, 2x. Let's see, and I'll get that from this line down here. That's equal to the integral cotangent squared 2x, cosecant squared 2x. And then I think we just evaluated that that's the blue integral there, and the value of the blue integral is, remember it has a minus in front of it, negative 1/2 cotangent 2x minus x. And we'll clean that up in just a second. All right, so this integral here is a u substitution. Let u equal cotangent 2x, which is going to make du negative 2 cosecant squared 2x. Okay. So we're going to replace that. Oh, I forgot my dx here. We're going to replace that cosecant squared 2x with negative 1/2 du. All right, so this becomes negative 1/2 integral u squared du. And we can't forget about this part here. So let's pretty that up now. That's going to be plus 1/2 cotangent 2x plus x. All right, so this is now going to be negative 1/2 times u cubed over 3, so negative u cubed over 6. Okay, so the value of the red integral is negative cotangent cubed 2x over 6 plus 1/2 cotangent 2x plus x plus c. Are we done? Well, no, not quite. Almost. That's the value of the red integral. Okay, now maybe I should have left 3 pages for this one. Okay, well, let's get rid of this part up here. We're done with that. Okay, so now we're finally ready to deal with the main integral. So let's remind ourselves what that was. So that was integral cotangent to the 6th 2x. Okay, and we'll take that from this line right here, that's going to be equal to the integral of cotangent to the fourth 2x cosecant squared 2x. All right, and then minus the value of the red integral, which is right at the bottom of your screen. This is kind of a long problem, huh? Well, that happens, especially in Calc 2. Wait till you get to differential equations, right? And linear algebra. Okay. So this is another substitution. I think we have everything we need from this part here. Now, I will admit that sometimes I may forget to write plus C, although I have really kind of had it drilled into my head not to forget that. You may be thinking right now that I've forgotten it, but really I'm thinking of it as being part of this, this integral right here that we have not evaluated yet. So I will write the plus C as soon as there is no more integral here. So this is another substitution. We're going to let u equal, and it's the same substitution we did before. So let u equal cotangent 2x. That's going to make du negative 2 cosecant squared 2x, which means that cosecant squared 2x is negative 1/2 du. All right, so integral cotangent to the sixth 2x is going to be the negative 1/2 the integral u to the fourth du. All right, and now this other part can become plus cotangent to the third 2x over 6 minus 1/2 cotangent 2x minus x. We're almost done. Okay, so value of that integral right here is negative 1/2 times u to the fifth over 5. So that's negative, you know what? Can we just write that here? Negative u to the fifth over 10, and then I'll write my final answer at the bottom. Okay, so writing it back in terms of x, we get negative cotangent to the fifth 2x over 10 plus cotangent to the third 2x over 6. This has been bugging me that sometimes I write the fraction in front and sometimes I put it underneath like that. So I just want to be consistent. Minus x, and then of course no points if you don't remember the plus c. Just kidding. Yes, some of these problems are long. We just have to deal with it. I'm sorry. I don't make the rules. Okay, but the good news is we're almost done. I just have one more little thing to show you. All right, would you like to go back to sines and cosines? I would. All right, and that is products of sines and cosines. For example, the integral of sine 2x cosine 3x dx. I forgot to write this down as an example. Okay, I only wrote the, so let me scribble this down real quick. This relates back to a section in pre-calc that I always try to cover, remembering that this is going to come up in Calc 2, having to do with the product to sum formulas. Okay. So the product to sum formulas, which this is another formula that I don't have memorized. If I was stuck on a desert island and I needed it, I would derive it. All right, so these are the product to sum formulas. They are derived from the addition formulas for sine and cosine. Okay. And if you want to know the details, maybe I will link my video on this section. I'll link it in the comments on this video. That's what I'll do, just in case your pre-calc instructor didn't cover it. All right, so let's see. I had better write down this formula. Sine mx cosine nx is equal to 1/2 times the sine of m plus n times x plus the sine of m minus n times x. This is not a calculus formula. This really is a pre-calc formula. All right, so now switching over to the tablet. Oops. We are going to rewrite this integral, sine 2x cosine 3x, as 1/2 the integral of sine 2 plus 3 times x, which is sine 5x, plus the sine of 2 minus 3 times x. Let me not skip steps here. Okay, so now I'm just going to do one more thing before I actually do the integration. Remember that sine is an odd function, which means that the sine of opposite x is equal to opposite sine x. All right, and now this is a very easy integral. By baby u substitution, the integral of sine 5x is negative 1/5 cosine 5x. And of course, the integral of negative sine x is plus cosine x plus c. I think that's pretty enough. All right, so now the official example. You know what? I'm just going to put it up here on the tablet. There's no reason to switch back to the presentation. Is integral negative pi over 2 to pi over 2 of cosine x cosine 7x. So the pertinent product to sum formula for that, again, I don't have this memorized. I am looking at the presentation, even though I don't have it up on your screen, is cosine mx cosine nx is equal to 1/2 cosine of m plus n x plus the cosine of m minus n times x. I did not use quite as many parentheses as they did. I think that's good enough. Okay, so that's going to make this integral negative pi over 2 to pi over 2 cosine x cosine 7x. It occurs to me that you could probably do this integration also by parts. But believe it or not, I think this is simpler. Okay, so 1/2 the integral negative pi over 2 to pi over 2 of the cosine of, remember there's an invisible 1 here, so the cosine of 1 plus 7 times x is going to be the cosine of 8x. And then the cosine of 1 minus 7 times x is the cosine of negative 6x. Now, cosine is an even function, which means that the cosine of negative 6x is exactly the same as the cosine of 6x. So when I go ahead and do this integration, I'm just going to pretend that this says cosine 6x because that's what it is. All right, so by baby u substitution, the integral of cosine 8x is 1/8 sine 8x. The integral of cosine 6x is 1/6 sine 6x. And now we're going to plug in pi over 2 and subtract the value at negative pi over 2. And I don't think there's all that much to go. So let's just squeeze this up here. I have a feeling I know how this is going to end up. All right, so we are going to have 1/2. First plug in pi over 2 gives us 1/8 sine of 8 times pi over 2 is 4 pi plus 1/6 sine 6 times pi over 2, which is 3 pi. Then we're going to subtract the value at negative pi over 2. So that's going to be 1/8 times the sine of negative 4 pi minus, plus 1/6 times the sine of negative 3 pi. And guess what? I hope you don't feel too disappointed. Every single one of these terms is 0. Right? Okay, so the value, I do kind of feel a little let down by that. All that work. I mean, it's kind of a silly way to feel, but yeah, at the end, everything just evaluates to 0. So the value of this definite integral is 0. And we have finally reached the end of section 8.3. So I hope you had as much fun as I did, and we'll see you next time.